one. So this is about largely especially advanced part of MySQL. So it's actually kind of hard to do that part, but I need to see actually more about explanation of concept with MySQL statement, because I can ask you to write statements. It doesn't make sense to have your memory of statements either. It's more about looking at something to try to connect things with concepts, connect some MySQL stuff with concepts. The first one, what this simple MySQL statement. This is probably the simplest possible subquery. Yes, and second, so nothing to explain if you get wrong. So think about what these two select does and look at the results. Sorry, I had a cold, so the next one, which is longer, which use exit rather than in. So what is this one? But look at every single keyword in this description. Nothing should be exists. It should be exists, I think, not exists. But it doesn't matter, this is not really a syntax. Okay, good. So the difference, because we have not. Okay, the next one, select from select, in-banded select. But in-banded select, that's it should be set in section. So, quite interesting to see that the first one and the last one was selected concurrently. In-banded things basically means you select something using one condition, and then you further select something out of the results which you just get from the first select using some further conditions, okay? Which actually normally can be rewritten as select star from the table where simply with more conditions put together using AND. And AND means intersection, not union. Of course, if you select B, I don't quite sure. I don't really know what you mean. So maybe you can do something different if you want to do something. But in the intersection. Next one. Join. So if you join two tables, simply left hand, so what this one does. Oh, sorry. Broken from time to time. Count down how many job is for trouble. I forgot we just count down for this one. Okay. Sorry. Oh. So simple join. So staff join module without anything else, simply to the join. So you probably see the answer already. So, but the main purpose of this is not about getting it right, it's not about repeating stuff which we learned last time. Simply joining two tables. Okay, this is other three CI. So joining the two table basically means three things. So it's either called Cartesian product, mathematically speaking, and we can all call it cross join in terms of relational database, or vector or inner join without a joining condition, or joining condition. It's not the other, because the other are different things. Next one, left outer join and the right outer join. If you put the union of those two, what would be that? Set union of left outer join and the right outer join. Forward, yes. Put left and right together, you have both the rows not matching from left into the right, and you also have the rows does not match it's in the right, doesn't match to anything in the left. Next one. What if we switch union intersection? So if you intersect a left outer join and right outer, what you look at. This is not covered in last week, but it can be derived from the definition of left outer join and right. Yes, so this is B, because left outer join means inner join includes the rows in the left which do not match to the right. Right of the join means inner join plus the rows in the right which do not match to the left. By intersect them, so only the inner join part will match. Okay, so this I should finish. I will keep this until later. But, I'm not sure if I will have time. If not, I will move it to the tutorial. So let's move on to the main part of today's lecture. So data modeling. So, as I said, the data modeling actually will be a starting point of the coursework. So this lecture is quite important. But why it's later at the end of the lecture? Because it's better you have some hands-on exercises about the relational database, and then you move on to more complicated stuff. So these are the things more abstract, and which will be useful for database design, and so you will see what that means. So database design basically means, suppose you have an application or topic, or your individual topic, and your individual topic or application has some kind of data structure. So then you normally, when you have to design something, you have to represent the data in some way. Normally, even your XML, you can consider XML as this database. And then you will actually do some database design or data modeling, either explicitly or implicitly. And until this point, largely speaking, you do it implicitly. Like if you put it into XML, you have a tree structure, you have DTD. You probably just do it because you saw this is the way it should be like that. So without thinking about why, or without thinking about, is there a better way of doing that? For instance, if you change the structure of the XML, you may end up with the two files, but put them together, you have less files. So you don't have more, you don't have redundant data state, things like that. And then what we are going to do today is basically to do it explicitly. So think about some particular topics that you have, and then think about what kind of data you have, and think about what actually are the things you want to record in some way. In database, in or XML. So we haven't talked about really implementing yet. We talk about design because we don't really care too much about how we are going to implement that. We only think about the data, at a very high level. And then we see how this becomes structured. And once you have that, so it will be fairly simple just to translate your design or your structure, which actually you will sort into activities or design. And this process not necessarily produce relational database. Although relational database is the one which actually widely used, but you don't have to. So for instance, if your data is very hierarchical, then you will see that relational database is very tricky to work with this kind of hierarchical data. Okay, moving it aside. So this is the root software, always automatically install. I keep uninstalling. I haven't collapsed the source of that. There must be some other more different software which has to trigger this. This is Chinese one. Yes, but this blocked me from continuing. Restart, but I'm not. I have this option. Self-respecting Okay, okay. Anyway, so I probably can't keep going because I know what the next slide has to show. But I want you to see my mobile phone. And so this is the usability of software. So they tell you that the option is recommended, but there's no option. It's not recommended. Or maybe they're hidden somewhere. Database design, so it's actually about if you have some piece of data. So think about the department example. So we have people, department, factory. We also use the center, which has a composite number of people. So these kind of things, which actually the application on the data which we are talking about. And then for this week, what we are going to do is use something called entity relationship modeling. The entity relationship modeling is a way of doing data modeling rather than database design. But it is a very good tool to do the database design by modeling data in a good way. So the entity relationship modeling is called ER modeling because it's entity E and the relationship R. It also has an enhanced edition which will be covered next week, which is called enhanced entity relationship model, which is something very similar to what we are doing in Java. So it's very especially much similar to classes. So probably we will not cover that today, next week. So the entity relationships model basically classifies stuff, data you need to store into two large distinct categories. One type of information which you actually need are objects. Yeah, it sounds very similar, familiar because of your work on Java. This is not the object in Java, although they have the same source. So the object could be physical, which means a person, a table, a room, department, you know what those are related. It could be conceptual, like a course, which actually is quite conceptual because it don't have something tangible, or some other stuff like even like actually a website. If you are a website design for people implement it, it could be actually a object as well, if you want to call it that way. But anyway, so one class is object, one category is object, and the other category is called relationship, which means between different objects, either two, maybe three, maybe more, they actually may have some relationship, which is exactly what English means. You have object, and object may have relationship. And then if you can make the objects clear, you make the relations clear, and then you know all of those are what you need in your application, and then you will formally write them down, and then you can then translate them into relationships or XML or whatever things you like to implement using the data. So this is largely speaking what the ER modeling is doing. And for the entities, as you can think of, so entities means objects, if we use the term, and the very important, or probably the only important thing about entities are something called attributes. So it's very similar like the member variables in class. If you always want to make link to classes, which means every single object, no matter physical or concept, they have some kind of properties. So room, size, location, which means in which building. So structure, so like that, or flat, or some other things. Equipment. These are the properties which we call attributes. So once you have entities, then you have attributes. With that, you make it clear that when you talk about objects, you know what kind of object you are talking about. You talk about this particular object has this kind of properties, and that one has that kind of properties. And they are different. They are different entities or objects. And then you talk about this one has a relationship with the other, and this one has a relationship with yet another one. And so you have a number of different relationships. And then you also categorize the entities of objects into different types. So me and all of you are all persons. And the room, all the different rooms, classroom and office and the seminar room, whatsoever, space left room actually all belongs to some kind of room type. And table and chair and different kind of furniture, they belong to kind of furniture that have those common properties or common structural properties. And similarly, you can do this for relationships because different kind of types, different type of entities can have different types of relationships, and even the same type of two types of entities, if they are actually exactly the same, but they could have also multiple relations which are different types. And then you then start putting things into different types, and then you will actually clarify what actually are the data which you are talking about. Okay, so let's start. Yeah. So we talked about already entity relationship. So actually I'm already talking about something here. Entities, relationships. So entities contains attributes, relationships may contain attributes as well, but we will come back later to that. And examples. So like students, modules, these are called entities and relationships. You attend module, and I'm teaching module. Students attend assessments. Researchers, papers, journals, awards. So authors, researchers authors paper, and journal publish papers, and research get awards, for instance. So this can go more. So once you have a clear idea about your data, so what kind of entities you have, what kind of relationship you have, you can visually represent the model of the data. And we will see how. But this is called ER diagram. It means you first have a model, but it could be very conceptual, which is probably hard to say. You can put it in here or on paper, but draw it in a very informal way. But they think, oh, I need to draw it in a better manner so that people can understand. If I show to anybody, then anybody could easily see, oh, I know what you mean, you don't need to explain. Or because it's so well defined, you can even automatically process it, because you know actually this data you have OCR, scan a piece of data and get all the structure recognized. In principle, this can be done as well. So this ER diagram is really give a way clearly represents your idea about model. This is one example of the family algorithm family project model. The model itself, of course, is a special model which allows you to select projects which are proposed by academics, and this is just to give you an example about what that looks like, and you will gradually learn how you can actually draw this. So we will come back to this at the end, and after we implement our pieces between. But this is how it looks like. It doesn't look like very complicated, but it does seem to have some complicated things in there. Even smaller stuff. Actually, the smallest stuff in this figure actually is the most complicated part. Especially in this one. So I will talk about me. the later. Okay, so entities first. As I said, entities are objects. So I'm an entity, and you, all of you are entities. When we put things together as a type, we say we are all persons. So we are actually talking about entities sharing common properties or entities. Very similar like that. So entity type is considered as a collection of all entities of the same attributes. The same attributes doesn't mean you have the same value for attributes, but they just mean you have the same attribute name. For instance, we all have name, we all have gender, we all have age, and we all have birthday actually, and some others. And to represent entity type, not entity, because you normally don't represent entities in your design, because you are designing the structure of the data, you are not designing the data themselves. So all class are entities, but this is not actually the data which you want to model, because you want to model the structure, model the concept, the content can change. This could not be about us, could be about my class. This is why we look at type, entity type, which means the class, the whole collection of everything. So representing an entity type, is very simple. Use a rectangle and put a name in. So the name is normally singular because you are talking about a class of individual things. And as is this individual, very abstract representation of every single of us. In this case, this is put academic, which means every single academic staff. So what every single academic staff actually has some common attributes, and you can represent that as a rectangle, and put the name in. Another concept, very similar to relational database. So you have entities, every single of us. You have a type, collectively. We all belong to a type. But if you are talking about a number of entities which actually you have, then you are talking about an entity set. Okay, which is a very simple term. And this is correspond to something in the relational database. So hopefully you can recall. Now, let's go back to V7, I think, here. So you look for the table and you should see something very related to this in I think one of the rows in that table is set. Okay, very big exercise. My laptop, this one, which actually just had problems with AVG antivirus software. Is this one the entity type entity set or entity instance? Entity instance is just entity, it's a different name. Entity instance is the same. Both, because entity instance is just a different name of entity, but not set, not type. So my laptop and my office workstation put together, what they form something called problem again. Okay. So it's again caused by the come down. short and very quick forget one. Okay, please read past your work. So count down the missing to this one properly. So state my laptop and my office workstation, 2 computers for okay, yes, and set. And the next one, all computers belong to not only the 2, but yours and any others. Yes, and it is good. So you have, nearly most of you got the idea of entity, entity type, entity set, and entity instance as the entity. And then we go to attributes. So we talk about entity type, basically means all the entities with the same attributes. So, and then how we represent attributes? So very simple. So you have a rectangle. Put the name in, which is entity type. Attribute is equal to ellipse. Put the name in, which is the name of the attribute, and link it with entity type. So you know this is attribute belonging to this entity type. Okay. Examples. So if you read things for computers, a lot of stuff between frequencies, screen size, and memory, hard disk, model brand, and a number of other things. So, don't list off all of them. Because there are normally a lot of attributes, and different attributes do have different nature. So, there are a number of different types of attributes. So the first way of categorizing them is something called simple attributes, we as composite attributes. So composite attributes basically means attributes can be further break down into sub attributes. So like names can be actually split further into first name and last name. And birthday can be split into birth month, birth year, and birth date. And birthplace can be split down into birth country and birth province or city or town or something like. You know how to do that. So, and the simple attribute, of course, is the opposite, which means they are standalone and they cannot be split further. So, by standard, for instance, which of course cannot be split further because it is atomic. And the representation, of course, is simply you have multiple sub-attributes, ellipse, and then a line linked with actually the composite attributes, and the composite attributes will be connected either with another attribute, because if you have a tree of actually this kind of composite attribute, because one composite attribute could be a sub-attribute of another composite attribute, but finally they will be all connected with an entity type, so that it belongs to the entity type at the end. So another 2 categories are also called derived and stored. The derived and stored are very simple. So the derived actually simply means they are actually not necessary, so they can be derived from others. Very typical example is age. So age is often something which you immediately think of, oh, this is an attribute. But it's actually not really the most important attribute because the most important thing is the work thing. Okay, that's great. The age keeps changing, even on a daily basis. So this means when you actually derive a database, or when you design your data, when you model your data, you will see, oh, the age is not something important. I should not include it in my data. It should be just a matter of implementation. If you want to implement, you want to show the age, do it separately, just do the calculation. Don't really store it in the database. You may have a problem updating that, but it keeps changing. And stored attributes, as the name says, stored means you need to store it. If you don't store it, you cannot get it from somewhere else. You have to store it, which is not derived from any other attribute. Another concept is also very simple. Multi-value or single value. Okay. Notation. Derived attributes dash line around the ellipse. A dash line always means, oh, it looks like something you don't really need. You can delete it. Another category is about multi-valued and single-valued attributes, which basically means some attributes can take multiple values, even addresses, and even offices, and some other things. So for computers, if you have multiple hard disks, multiple screens, maybe, I'm not sure. And at least some computers have multiple screens. And the single value attributes, on the other hand, especially only means you only have one single value. So this is in many cases for most other attributes. So notation-wise, double line. So it's clear, double line means true. Of course, it can not only mean two, it can be more. But you don't do more because we look hardly. So they are all quite easily to guess, even when you look at them. Another thing which is interesting also familiar with to you is called identifier attributes. So identifier attributes basically offer entity type basically gives you a particular attribute which allows, which actually identifier is something which you already select. If you select, sometimes you can easily identify a single entity in an entity type, like person entity type. And if you need a way to uniquely say which entity you're talking about, to select a particular attribute and say I use this, so this one is really unique for every single entity in this type. So realization underline below the name of the attribute. Very simple. You will only have one, or maybe you don't have any. And of course, you could also have candidates, or it's simply called unique. And this of course needs to have a number of requirements, but these requirements, as you can see, can be easily derived from the need to be actually uniquely, to be able to uniquely identify every single entity. So of course, they have correspondence to relational database, and you immediately realize, and they are so close, and you probably wonder, are they basically the same thing? But of course not, because we are not talking about relational database design, we are talking about data modeling independent of relational database. So they are similar concepts, that means just because we have the same needs, you need to identify something. Okay, very quick thing. Identify your relational database. Just recall if you get what I just said about the relational database.